Next topic is the equivalent component, or we can say equivalent component. It can be RLC. See what happened in this question, in this topic. We will have some network, okay, and from that network we have to calculate the equivalent resistance, inductance, or capacitors that is asked in the question, okay. But why we use this concept? Why we use this concept in a practical life? Anyone can give me the idea where we use this concept in a practical life? Tell me where we use this concept in practical life. See, you all have seen the electric tower out of your house, okay? In electric tower you have seen there are so much wires, there are so much cables going on through, right? There are so much wires, there are so much cables. Let's suppose we have to find out how much power that tower requires. So for finding out how much power that tower requires, we have to know how much power loss is happening in that wire, in that tower. Or I can say power loss, the formula is simple, which is nothing but I square R. See, if we know the resistance, I can calculate the power loss that is happening in a tower. But if I go through each and every wire, it will take much time to calculate it. For example, if a transmission wire have 100 wires and then 100 cables also, it means we have to calculate each power of each wire or each cable. That will take a much time. But if we calculate the equivalent resistance, then I can convert that 200 wires into a one wire, right? And then we can easily calculate how much power is required to transfer it from one point to another point. This is one application why we require equivalent resistance, okay? Or I can say to calculate the total heat loss, to calculate the total power dissipation, we require equivalent resistance. So in a practical life, this concept is very much important, okay? And when we will do the chapter 2, which is the network theorems, you will see in Thevenin's theorem and in Norton's theorem, we have to find out the total resistance, okay? So for application in Thevenin's and Norton's theorem, this concept is also important. Now we will see from the exam point of view. See, in GATE exam, this is a trend that after every 2 years, it is asking questions from this topic, okay? For in 2018, it has been asked. In 2019, there was no question from this topic, so it is high chance that they can ask in 2020. Okay, so for the 2020 exam, this topic is important. You can star mark it. Okay, so in this topic, we will see the different type of networks and a different configuration of network, and we will see how to calculate equivalent resistance, inductance, and capacitance. Okay, so before going to that, some basic we have to know that what is series and what is parallel. Because most of the students do mistake to identify the parallel network, parallel branches. Series branch is easy to identify, no problem. But most of the students face problem to identify the parallel branches. Okay, so we will see what is the meaning of series branch, how to identify which branch are in series, and then we will identify which branch are in parallel. Okay, simple 2-minute topic. So tell me, how will you identify two branches are in series? You tell me first. How will you identify two branches are in series? Tell me. How will you identify two elements are in series? If same current is flowing through it. Not in this diagram. See in this diagram. Just I'm asking. How will you identify the series? So Pooja says same current flows through it. Okay. So according to this definition, if somehow I say this is 2 ampere and let's suppose this is 1. So according to your definition, Pooja, according to your definition, if the same current is flowing through two branches, they are called the series. But you can see, I'm saying from R1 2 ampere is flowing, then there is a network. In network we can have anything. Then in R3 again we have a 2 ampere flowing. So can we say R1 and R3 are in series? Can we say R? No, correct. We cannot say R1 and R3 in series. It means your definition is not complete. Point is correct that the same current will flow. This is one of the point to identify series. That one point is what? Same current will flow through branches. Okay. One point is correct to identify, but this is an incomplete point. Second point, can anyone tell? See, I'm talking about series, okay? I'm taking two resistors. This is R1, this is R2. From seeing that, I can say this is in series, okay? No problem. Now, let us suppose from a second point, we have to find out the second point. This is terminal A, this is terminal B for the R1. Okay? This is terminal C, this is terminal D for the R2. Okay? So in series connection, if one terminals of both branches are connected to each other and other terminals are independent, then that branches are in series. Means one terminal of both branches must be connected to each other, and other terminal must independent. These 2 points are must be satisfied to say two branches are in series. What are the points? That same current will flow. Second point is one terminal of both branches must be connected to each other and other terminal must be independent, which means they are not connected to each other. Okay, this is the one point to find out series. But series identification is so much easy. Okay, anyone can tell these two elements are in series or not. The question arises for the parallel. Okay, the question arises for the parallel. Parallel branch. This is important and most of the students do mistake to identify the parallel branch. First point, everyone knows same voltage across branch. Same voltage across the branches. Second point is important. Let us suppose these are two branches, you can easily say, and you know these two branches are in parallel, R1 and R2. Okay, now we have to identify why they are in parallel. See, this is terminal A, this is terminal B, this is terminal C, this is terminal D. So for parallel branch, see carefully, for parallel branch, both terminals must be interconnected to each other, then that branches are known as the parallel branch. It means both terminals must be interconnected to each other. Then branches are parallel. And it is important thing, students, because most of the students do mistake in that. Okay, when we will see the complex network, in that you will see the importance of this point. Okay, so if both terminals are connected to each other, then they are in parallel. Okay, this is just the identification of series and parallel. So whenever you want to identify the parallel and you are not able to see by seeing the diagram, the easiest way is to give the terminals to all the branches. And if the two branches have the both terminals connected, then they are known as the parallel. Okay, that we will see in upcoming questions. Okay, so this is the 2 points to identify series and parallel. Okay, now I am writing just some few points that for resistor first. Just a few points to remember this. If n resistors are connected in series, then total resistance is equal to R1 plus R2 plus Rn. Similarly, if n resistors are connected in parallel, then total resistance is equal to parallel combination of each and every resistance. Okay, so this you know. Same is the case of inductor also. In inductor, I can say total inductance is L1 plus L2 till Ln, and in reciprocal also it will be L1 L2 Ln. Okay, so the same case is for the resistor and same case is for the inductor. Okay, the important thing is now is for capacitor. In the capacitor, formula is opposite. In capacitor, see, in capacitor, if we have n capacitor in series, then total capacitance 1 upon Ct is equal to 1 upon C1, 1 upon C2, 1 upon Cn. And if I have n capacitor in parallel, then total capacitance is summation of each and every capacitance. Okay? I hope you don't have any doubt here. If you have any doubt, then ask me. Otherwise, this is the part you have learning from the 11th, 12th. Okay? So just quick review of that. So now we will solve some question to find out the equivalent components. Okay? And from the questions we will see which technique we should use to find out. Okay? So first question is coming. This question. Try to solve it. Find out total resistance. Or you can see the question on PPT. You can see the question on PPT. You can also solve in that way, that we have to find out the value of find RE by R. Okay, so this is the question. You can see the question PPT also. Okay, try to solve this question. So we will solve this question. See carefully. In this question, what is given? We have given some resistance, and in the end we have an infinity attached, which means this same model is repeating till infinity. So first of all, this is the infinite ladder question. This is the infinite ladder question. Okay, infinite ladder question, in which we have some branch repeating infinite time. It is known as an infinite ladder question. So to solve this question, we have few steps. See, this type of question are very much popular in case of IIT JEE. Okay, if you remember 11th to 12th class, you have already done this type of question there. Okay, so this type of question is very much popular there. Okay, but this is a simple question. What you have to see, first of all, see which branch is repeating infinite time. Okay, first of all we will see which branch is repeating infinite time. See here, this R and this R. This is 2R. This is not repeating. This R and this R. This is repeating infinite times. Correct? This portion is repeating infinite times. Now tell me one point. Infinity plus 1 or infinity minus 1. Both will give you the answer of infinity. Right? If I add one number in infinity or subtract 1 from the infinity, you will get same answer, infinity. Right? So what I am saying, why I am saying this, you can see that if I am adding one more resistance branch in infinite, again the network will be same. Or if I am removing one more branch from this infinite network, again the network will be same, because infinity plus 1 and minus 1 give you the infinity. Now see here, the first step is to identify which branch is repeating. We have identified this branch is repeating infinite times. Okay. Now I can say for this portion, for whole this portion, I am assuming resistance is X ohm. I am assuming that for whole this portion, the resistance is X ohm. So now I can remove the whole part. And I can put here resistance X ohm that I have assumed. X ohm that I have assumed. X ohm. Okay. Now see. In this X ohm, I am adding one more branch that was repeating. Which means here X is what? X is nothing but this thing. X is this thing. Okay. Now in this I am adding the same branch here. So if I add same branch here, then there will be no effect on the resistance, because if I am adding one thing in infinity, it will again the infinity. So what I am doing, I am adding one more branch here. Again it will be what? Infinity. So again the resistance from this point again is how much? The resistance will be X. Right? So I can say that resistance will be X for this much portion. So see, I am repeating again that first of all, identify which branch is repeating infinite times. Okay, first of all, identify that. So we have seen that this branch is repeating infinite. Then leaving that branch, when the repetition start, I took all the portion equal to X ohm. Now I am adding same branch in X ohm, then again it will give the result X, because if I am adding infinity plus 1 or minus 1, it will be no effect on the answer. So I can say what is the value of this X, These two are in series and parallel with this R, it is equal to X, right? So I can write X is equal to, these two are in series, R plus X, and parallel to this one, which is nothing but R, right? This X is equal to what? These two are in series parallel with this. So from this we have to calculate the X. So R plus X multiplied by R divided by R plus X plus R. Okay. So from here I can write XR plus X square plus XR equal to R square plus XR. And from here I can find out X square plus XR minus R square equal to 0. Right? From this I have to calculate the value of X. So this is a quadratic equation. This is a quadratic equation. We can calculate the value of X. X is equal to what? Minus V plus, minus V plus minus B square minus 4AC divided by 2A. Okay? This is the formula of the quadratic equation. You already know. Minus V plus minus B square minus 4AC divided by 2A. So it will give you minus R plus minus root 5R by 2. So from here we have two values. One is minus R minus root 5R divided by 2. Another one is minus R plus root 5R divided by 2. Again, the resistance cannot be negative, so this cannot be the answer. The value of X is what? This one. So X is how much? Minus R plus root 5R divided by 2. So till here, there is any doubt? Till this step, do you have any doubt? If yes, ask me. Okay. So X comes out minus R plus root 5R divided by 2. But the question is not complete. We just find out the X, right? Means that diagram is now reduced to what? The diagram is now reduced to this. This was X, right? So RE is how much? RE is equal to, these two are in series, 2R plus X. R is this, 2R plus X, right? So 2R plus X equal to 2R plus X is what? X is root 5R minus R divided by 2. When you solve it, it becomes 2 to the 4 minus 1, 3. 3 plus root 5 by 2 bracket R. So this is the answer. Okay, solve it by calculator. This is the answer. Okay. So tell me one thing in this question. I'm making a diagram again. Tell me, which two resistors are in series in this diagram? Which two resistors are in series? Tell me which two resistors are in series. R0 and R2. Okay. last two, R3 and R4. Okay. R0 plus equation R. Okay. So let's see which two are in series. See, what is the basic 2 points to identify the series? The points are the current flow must be same. Second point was one terminal must be connected of both branches. So see here, if the current I is flowing in this direction, I is flowing here, it is a node. Current must divide here, which is I1 and I2. Again I2 is flowing, again we have a resistor. Then again current is divided in this I3 and I4. So you can see R0 and R2, same current is not flowing, and the same current is not flowing. First point is wrong. It means R0 and R2 are not in series. Similarly, Shivam, you gave last two. In the last two, you can see this is I3, this is I4. Again, same current is not flowing. And if the same current is not flowing, they are not in series. So the answer is no series resistor here. For finding out the series resistor, same current must be flow. First point. And you can see same current is not flowing. And the second point was the terminal must be connected to each other. But we will see the second point when the first point is right. But you can see the first point is wrong. They are not in series. They are not the same current flowing. So they are not in series. Now tell me which two branches are in parallel? Which two branches are in parallel? Tell me. For the branches, first of all, first point was we have to see the voltage must be equal. But voltage equality we cannot check because we don't know the value of resistor or we don't know the value of current. So voltage we cannot check. Because for finding out voltage we have the value of I and R, and both we don't know. So we will see the second point. If the second point was correct, then I can say two branches are in parallel. Okay, so see here. I told you if you don't know which branch are in parallel, just give them the alphabetical name to the terminals. See R0. I can see this is A, this is B. Okay. For R2, C, D, and E, F, and let us say this is G and H. And if two terminals of both resistors are connected to each other, that will be a parallel. So see here, you can see B and C are connected to each other, right? But other terminals A and D, they are not connected to each other. And if they are not connected to each other, this is not parallel. Again, R0 and R1, you can see B and E are connected to each other. But again, A and F are not connected to each other. So again, R0 and R1 are not in parallel. Again check R1 and R2. C and E are connected to each other. But again, the other terminal D and F, they are not connected to each other. So again, they are not parallel. So means again, this what? No parallel resistors. No parallel resistors. So understood this point? Yes or no? How to identify series branches and parallel branches? Shivam Singh, you said, but by definition, it is series. See Shivam, in series I told you 2 points. Remember, the basic point is that same current must be flow, and the second point is that the one terminal must be connect each other. So second point is correct here. B and C, one terminal is connected, but same current is not flowing. So these are not in series. Okay. Now we will see the next question. Find out capacitance between A, B, and all capacitors are equal to C. Okay. Find it. Find capacitance A, B. See guys, this question. In some question, it is difficult to see which one are in series, which one are parallel. For example, in this question, some people can see which are in series, which are in parallel, but some people can't. Okay. So in this type of question, what we will do, the first step is to name each and every node. Okay, just provide name each and every node, and then we will redraw the network. See, what can I say? This is A and B. This is C. This is D. A, B, C, D, and now this node. Now you can see from B to this node, there is not any element present in a path. You can see from B to this node, there was not any element present in a path. And if there is not any element present in the path, then both this node will be at same potential, and that 2 points are known as the equipotential points. So what does it mean? That if between 2 points, if between two nodes, not points, sorry, if between two nodes there is not any element present, then there is not any voltage drop occur. For example, if this is 2 volt, there is not any element present in this branch. So this here the voltage is also 2 volt because there is not any voltage drop. Then both node will be at the same potential. So see here, B and this node, I am flowing in this direction. There is not any element present here. I am electron. I am flowing from B to this node. So I am not facing any resistance. And if I am not facing any resistance, there will be no voltage drop across it. So whatever with the voltage here, the same voltage will be here, right? So I can say if this is point B, then this point is also B. Got it? This point. That if between two nodes there is not any other branch, then the voltages of both the nodes will be equal, and that is called equipotential nodes. And we can naming the same alphabet to both the nodes. So this is B, this is B. Okay. Now we will redraw the diagram. So we are redrawing the diagram. So you can see this is A, this is B, let's suppose this is C and this is D. Okay, now see, from A we have one capacitor to B and one capacitor to D. Let's suppose take it as a D. Okay, D and C. So from A we have one capacitor to B and one capacitor to D, right? These two capacitor complete. From D we have one capacitor to C and one capacitor to B. From D we have one capacitor to C and one capacitor to B, right? Now from B we have one capacitor to C, and again from B we have another one capacitor to C. So you can see these two are in parallel. From B we have one capacitor to C, and again from B we have one capacitor to C. Why? Because you can see these two capacitor. It has one node B, it has one node C. Again, it has one node C, it has one node B. So both nodes are connected to each other. That's why they are in parallel. Okay, so this is the best way to find out which elements are parallel. Just provide naming. Remember the equipotential concept? Just providing the naming. If two branches, if both terminals are connected to each other, that will be a parallel branch. Okay. So this is a simplified network. This is C, 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 capacitance C. Okay. So you can see these two are in parallel. So if capacitors are in parallel, their resultant will be what is 1 by Ct equal to 1 by C plus 1 by C. So Ct will be equal to C by 2. Right. Now this C by 2 and this C are in series. So I can write C plus, sorry. These two capacitors are in parallel, right? So for a parallel capacitor, Ct will be C plus C equal to 2C. Okay? Then this 2C and this C are in series. So I can write 1 by Cs equal to 1 by C plus 1 by 2C. Or Cs will be 2C by 3. Cs will be 2C by 3. Then here it is what? 2C by 3. So 2c by 3 and c are in parallel again. You can see these both are in parallel again. So you can write c dash c plus 2c by 3 is equal to 5c by 3. So now I have redraw the diagram again. It will become like this. This is what? 5c by 3. Right? Now see, these two are in series. Again, if these two are in series, c double dash will be equal to c multiply 5c by 3, c plus 5c by 3. So after solving this, you will see 5c by 8. You will see how much? 5c by 8. Now this is 5c by 8. Now again I can remove this. This become 5c by 8. Now you can see both are in parallel. If they are in parallel, we can add up. So capacitance between AB is 5c by 8 plus c equal to 13c by 8 farad. So this is the answer. Got it, Shivam? Your answer was not correct, I guess, or check my calculation if my calculation is wrong. Okay. If somewhere my calculation wrong, you can check it. The concept is this. Okay. So if you have any doubt in this question, ask me. The problem in this question is that we cannot identify series and parallel just by seeing it. And in that case, we have to redraw the diagram. And whenever we have to redraw the diagram, we have to provide name to each and every node. And after providing a node, we have to redraw the diagram. And then we will see that which branches are parallel and which branch are in series. Okay?